All right, hey guys, it's Mr. Holly. We're going to be looking at how to solve equations today. So we've done a lot of work with expressions, and we're going to be transitioning from just looking at expressions to looking at what would happen if we have two equivalent expressions and we write those as a number sentence or an equation. So today we're going to be using Algebra Tiles, and we're going to be looking at how do we solve using this tool of Algebra Tiles. So the first thing I'm going to do is just use a couple numeric expressions. So right now we're just going to look at 5 is equal to 5. And just to learn the rules with Algebra Tiles and with equations, I'd like to show you that whatever I decide to do with these expressions, as long as I do the same thing to both sides, they still remain equivalent. So for instance, if I wanted to subtract 1 from each side of the equation, I still have an equation. I still have two equivalent expressions. If now I wanted to divide this by 2, so 4 divided by 2, I would end up with 2 on each side. And now I still have equivalent expressions. 2 is equal to 2. Everything remains balanced and equal in this equation. So we are going to start looking at some variable expressions and trying to solve for x. So the first equation that we're going to look at is x plus 2 is equal to 5. So hopefully you remember these tiles. We use these with expressions, and you remember that these bars, the green represents a positive x and the red is going to represent a negative x, or the opposite of x. And then we've got the yellow counters, yellow and red, to represent positive and negative 1. So here I have the expression x plus 2 is equal to 5. So in order to solve for x, I think many of you might even be able to rationalize this without even manipulating these. You know, what plus 2 is equal to 5? Well, the way I would show that with the tiles is if I subtract 2 from each side of the equation, then x must have a value of 3. And you guys maybe thought of that on your own. 3 plus 2 is equal to 5, okay? So now let's do a few more equations like that. Let's just continue to see if we can solve for x by isolating the variable, getting it by itself and finding its value. Okay, so the next problem I want to look at is x plus negative 4 is equal to 1. X plus negative 4 is equal to 1. So in order to get x by itself, I would need to remove these negative 4s. So I would have to subtract negative 4. But if we think about this, go back to our integer rules, subtracting a negative 4 is the same as adding 4. So here I can just add 4 to create 0 pairs. And while I'm adding 4 on this side, I'm also adding 4 on this side, making an equivalent move over here. And now these unit squares, these 1s, create 0 pairs, and they actually can just be removed. 0, 0, 0, 0. And now I have x is equal to 5. So let's go back to our original x minus 4 equals 1. Well, 5 minus 4, yeah, that equals 1. That works. Okay. Let's look at the next one. X plus 2 is equal to 3. X plus 2 is equal to 3. I bet, again, this is one that you can probably figure out on your own. But let's use the Algebra Tiles so that we can get the procedure of using Algebra Tiles down. If I have 2 1s, in order to isolate this variable, I would need to subtract 2. I'm going to subtract 2 from this side as well. And now this variable is by itself, and we found that it is equivalent to 1. So x is equal to 1. All right. So far, all we've seen is if x had a coefficient of 1, just 1x. But now we want to make this a little more challenging. what if we had 2x? So here we have 2x plus 3 is equal to 5. Let's look at this equation. 2x plus 3 is equal to 5. And I have them written over here if you need to refer back to them. 2x plus 3 is equal to, oh, I take that back. It's equal to negative 5. Looking at this. Equal to negative 5, excuse me on that one. So 2x plus 3 is equal to negative 5. Right, now remember, my goal is to get x by itself. I want to find the value of 1x. In order to do that, the first thing I want to do is try to get rid of this constant term. If this were an expression, this would be like the plus 3, the constant term. So I need to get rid of these first. I need to try to get the x's by themselves. Now in order to remove these 3, I need to take away 3 from both sides. Well, if I look over here, there's not 3 that I can take away. I only have negatives on the right side. I can't remove any positives. But again, going back to our integer rules, removing 3 positives would be the same as adding 3 negatives. So if I was to add 3 negatives on each side, that would be an equivalent operation, do the same thing. I'm adding negative 3 here, I'm adding negative 3 here. This creates a 0 pair, and now I'm left with 2x is equal to, now on this side now I have negative 8. So now I have 2 x's are equal to negative 8. Now this is the first time we've had a situation where we have 2 as our coefficient of x. So we don't just have 1 x here, we have 2 of them. So in order to figure out what one of them is worth, I need to divide this into 2 groups. This is the way I like to kind of picture it. One group of 4 on top and one group of 4 on the bottom. So each x is going to be worth 4. So we can remove this one and say that x is equal to negative 4. X is equal to negative 4. All right. Let's go to the next one. Now we're going to take it, instead, we've seen x has a coefficient of 1. We've seen x with a coefficient of 2. Now we're going to look at x with a coefficient of negative 1. What if we have negative x? So this is going to be negative x minus 3 is equal to 1. All right, so again, we want to try to get x by itself. We want to isolate the x variable. So I'm going to, ideally what I would do is remove these 3 negatives, but I don't have 3 negatives to remove on this side. So in order to cancel these out, I'm going to need to add 3 positives because, again, integer rules, subtracting 3 negatives is the same as adding 3. So if I just add 3, I can create 0 pairs. I would also need to add 3 on this side. Now I have a constant value of 0, negative 3, positive 3, this creates 0. And I see that negative x is equal to 4. So as we've discussed in class, whenever we write negative x, what that really means is we have the opposite of x. So the opposite of x is equal to 4. So in order to see what x would be equal to, we would just say if the opposite of x is 4, well then x would be the opposite of 4, which is negative 4. And that's our solution. X is equal to negative 4. Another way to think about that is, I'm going to go back in time. Let's rewind real quick. Another way to think about this is that if I wanted to take both sides and multiply them by negative 1. So if I had negative 1x, negative 1 times negative 1 is positive 1x. So I would multiply that by negative 1. And then here, if I had 4 times negative 1, that gives me negative 4. So we can either think about that as multiplying by negative 1, or as taking the opposite of both sides of the equation. All right, let's look two more very quickly here. Negative x plus 2 is equal to 4. This one's going to be easy because we have positives to take away from both sides. So to get x by itself here, negative x plus 2 is equal to 4. I want to get negative x by itself. I can just remove 2 from both sides. And now I have negative x is equal to 2. Again, this is the opposite of x is equal to 2. So that means x would be the opposite of 2, or negative 2. All right, last one. This is as complex as we've been today. We're going to have a coefficient of 3, and it's going to be negative. So we've got negative 3x minus 2 is equal to 4. Negative 3x minus 2 is equal to 4. All right. Again, I would like to take away these two negatives, but I don't have two negatives to take away from this side. So what would be the same as removing two negatives? Well, subtracting negative 2 is the same as adding 2. So if I add 2 to each side, that creates a 0 pair over here, and I can remove these. Now I have negative 3x is equal to 6. And I need to divide this up into 3 groups, where each negative x is equal to 2. Right? So we can just remove these, and we see that negative x is equal to 2. After we divide it by 3 there, negative x is equal to 2. So the opposite of x is 2 would mean that x is the opposite of 2, or negative 2. And that's our solution. And let's check it, just for good measure here on the last one. We're saying that x is equal to negative 2, so negative 3 times negative 2, that's a positive 6. Minus 2, that's 4, and that works. All right, guys, hopefully this was a process that's going to help assist you as you try to solve equations. We're going to spend a lot of time doing that this year, so hopefully this helps.